one application about the calculation of the flux through a closed surface. We saw in the last videos that the total flux through a closed and empty surface equals to 0 in general equation. Let's say the flux of a closed and empty. What I mean by empty, we don't have any charge inside, okay? Fly of a closed and empty object through the closed and empty object equals to 0. We talked in the last video about a cube, and we calculated the flux through this cube. Now we have a horizontal field, a constant field with E equal 7.8 times 10 power 4 Newton per Coulomb, as shown in the figure. And we have a triangular box, as you see. Now I want to calculate the electric flux through the vertical triangular surface, I mean the back side of this object, let's say 1. 2, the slanted surface, the inclined plane surface, let's say part 2. And C, we have to calculate the entire surface, about the entire surface. We have to calculate the total flux through the object. So let's take, first of all, side 1, okay? Side 1. In general, before side 1, in general, the flux equals to E dot A, okay? Equals to E A cosine the angle between E and A. This is the general case. In this case, we have the total flux equals to flux 1 of the back side, where we have a rectangular surface, plus phi 2 through the inclined plane surface, plus phi 3 back side, and at the bottom, the side at the bottom, we have 3 side equals to the total flux. The summation of this flux gives us the total flux through the entire object surface. Let's take, first of all, side 1. Okay? Okay, side 1. And the side 1, A must be out of the object and perpendicular. So we can say A must be in this direction. This is A. So it's opposite to E. E is horizontal and the plane is vertical, so A must be opposite to E. So in this case, we can say flux 1 equals to E. Okay, let's say A1 here, A1. E, A1 cosine theta. In this case, theta, we can say equals to 180 degree, because here we have E horizontal to the right, and we have A is opposite. Okay? And A1, the area of the back side, is a rectangle equal to the length times the height. Okay? we have 0.3 times 0.1. Okay, we get 3 times 10 power minus 2 meter square. Okay, so the flux 1 equals to E. We have the value of E equals to 7.8 times 10 power 4 times A1 equals to 3.10 power minus 2. We get flux 1 equals to minus 2.34 times 10 let's say 10 3. Okay, we can say K. Okay, minus 2.34 K kilo. K, the unit is Newton m square per coulomb. You know, K equals 10 power 3. And the unit of the flux is Newton m square per coulomb. The unit of E is Newton per coulomb. The unit of A of the area Now I want to calculate the flux through the inclined side. Let's say side 2. Okay. In general, we can say flux 2 equals to E dot A2. E is in the horizontal direction and A is perpendicular to the plane. Here we have A. And here we have E. The angle between them equals to theta. Okay. So equals to E A2 cosine theta. A2 as magnitude equals to small a, the length, times the width, A times B equals to A times B. We have the value of A equals to 0.3. So we need to calculate the value of B. To calculate B, I take this right triangle. We can say cosine 60 equals to the adjacent. Let's say here we have H equals to H over B. So B equals to H over cosine 60. So A2 equals to 0.3 times H equal 0.1 divided by cosine 60 equals to 0.06 m square. Okay, we have A2, we have E, we have to calculate E. Theta here, theta here equals to 60. Okay, why? Because the plane, let's take a plane, a vertical plane. If we move the plane to the angle 60, okay, to the angle 60, initial position here has A1. Let's say here we have initial position A1 or A on general. The final position, initial, final, has A prime. Here we have A prime. The angle between here we move 60 degree. The angle between the initial and final A equals to 60. Okay, from here to here. Okay, so this angle equal to 60. Let's say between the new A prime and the vertical and the horizontal. So here, as you see, theta equals to 60. Now, we can calculate phi 2 equals to E. We are E equals to 7.8 times 10 power 4 times A2 0.06 times cosine 60. So phi 2 equals to plus 2.34 K kilo Newton M square over Coulomb. This is phi 2. Let's calculate for the phi 3. For the bottom, we have the bottom side. For the bottom side, phi equal E times A3. A3 is perpendicular to the bottom side. We have A3. The angle between A3 and E, here we have E, equals to 90. So the flux equal E A3 cosine 90 equals to 0. We don't have a flux through the third side, this side. We can say the total flux through the closed triangular box equals to phi 1 plus phi 2 plus phi 3 equal minus 2.34 plus 2.34 plus 0 equals to 0. Okay, equals to 0 Newton M square per Coulomb. Here we have a Newton. Phi 1, you have to add Newton M square per Coulomb. Now we see well that the total flux through a closed and empty surface like this one is equal to 0 in all the cases maybe you have in all the shapes, maybe here you have a triangle box. If you have a cube box, any shape, the flux through any closed surface must be equal to 0. Okay, thank you.